All right, let's try number 5. So we have 25 grams of oxygen, so that's oxygen gas. That's the only oxygen we have to mess with. React with 25 grams of acetylene. That's C2H2 here. How many liters of CO2 at 22 degrees C and 760 torr are formed? Okay, so when we look at this, you have 25 grams of oxygen reacting with 25 grams of acetylene. So right away, you know this is a stoichiometry problem, and the stoichiometry problem is a limiting reactant problem. So the first thing that we want to do is figure out what the limiting reactant is. So how do we do that? Well, let's figure out how many moles of each we have. So we have 25 0 grams of oxygen, and we know 32 grams of O2 is 1 mole of O2. How do we know it's 32? Oh, well, if we look on our periodic table, oxygen is 16, 15.9999, 16 times 2 since it's O2, so it's 32. So that'll give us our moles of oxygen. Let's figure that one out. 25 divided by 32, 0.781 moles of O2. Let's do the same thing with the acetylene. So we say 25 grams of acetylene, 24 plus 2. How do I get 24? Oh, because carbon is 12. So once again, carbon is 12 times 2 is 24, plus 2 hydrogens, each at 1 apiece, is another 2. So 24 plus 2, we'll call that 26. One mole of O2. Oh, sorry, that's not O2, that's C2H2 equals, clear, let's see, 25 divided by 26 equals 0.962. 0.9615, call it 962. To H2. All right. So now we have to look at our mole-to-mole ratio. It's a 2 to 5 molar ratio, mole-to-mole ratio. That is, for every 2 moles of acetylene, we react with 5 moles of oxygen. So instead of going 2 to 5, that's kind of a strange ratio. I'm going to go 1 to 2.5, just because it's easier. That means for every mole of acetylene, I need 2.5 moles of oxygen. Well, if I have 0.962 moles of acetylene, well, 2.5 times that is somewhere around, something just under 2.5, because this is close to 1. So because of that, I need more than 2 moles of acetylene to react with, I need more than 2 moles of oxygen, not acetylene. If I have 0.962 moles of acetylene, I'm going to need 2.5 times that number, because it's a 1 to 2.5 ratio of oxygen. So 2.5 times 0.962 is something more than 2. Well, do I have more than 2 moles of O2? No, I only have 0.781 moles of O2. So it's important that you do that mole-to-mole ratio. Real quick, this is the calculation I did in my head. And I didn't need a number, I just needed to figure out what it was. So if I have 0.962 moles of C2H2, well, I know for every 1 mole C2H2, I need 2.5 moles of O2. Okay, well, 2.5 times 0.962, that's bigger than 2. So I know that my limiting reactant is oxygen. Okay, so I'm going to work. So now I know what my limiting reactant is, so I can figure out how many liters of CO2 are formed. Why do I need to know what my limiting reactant is? Well, because I'm going to need to figure out how many moles of CO2 are formed. And the only way I'm going to figure out that is from my limiting reactant. Why do I need to figure out moles of CO2? Oh, because CO2 is a gas. And if I'm going to figure out the liters, the volume of it, I need to know the moles. So if I have 0.781 moles of O2, then I know for every 5 moles of O2, I produce 4 moles of CO2. So that, if I go ahead and figure this out, 0.781 times 4 divided by 5. 0.625, we'll call it. 625 moles of CO2 produced. Alright, now I'm ready. Now I have my moles, because if you look up here, I know my, let's see, I'm asking for pressure. Pressure is equal to 760 torr. But remember, 760 torr is equal to 1 atmosphere, so I'll say 1 atmosphere. My volume, oh, well, that's what I'm trying to figure out. It says how many liters. So volume I'm trying to figure out. My temperature, 22 degrees C, well, it's 22 plus 273. What's that? 295 kelvins. And my number of moles, well, how many moles of CO2 do I have? Oh, I figured it out right here. I have 0.625 moles CO2 produced. So now it's just plug and chug. If I use the equation PV equals nRT, okay, well, if I solve for V, V is equal to nRT over P. Now it's just a matter of plugging and chugging. V is equal to N 0.625 moles times R 0.0821 liter atmospheres per mole K times T, which is 295 kelvins, divided by P, which is 1.00 atmospheres. And what do I get? Well, V, when we figure this whole thing out, what do we get? Well, let's sort that out. You get 0.625 times 0.0821 times 295 divided by 1, of course, no big deal, and I get 15.13, and we're good to what, 366, so 15.1 liters. There you go. Real quick recap. 15.1. Okay. First, we had to identify the limiting reactant. We did that, figured out that oxygen was a limiting reactant. Then we can figure out how many moles of CO2 we produced. We worked from the limiting reactant, figured out how many moles of CO2 produced. Boom, that allows us to find N. That's N right there. So we knew the pressure from the problem. Figured that out. Volume we're trying to figure out. Temperature we were given, and we calculated. Plug it all into the gas equation. Plug that out all the way through. We get 15.1 liters.